Hello, it's Keith here, and this is lesson 6 of the platform specific series of my ARM assembly programming tutorials. Today we're going to be looking at the Game Boy Advance. We're going to be learning how to make a noise, so that should be fun. Okay, so what are we going to do? Well, we're creating something I call Chibi Sound. Now this is a very simple sound driver. It takes just a single byte parameter, and it's designed for the very simple beeps and bloops that you might make in a sort of Space Invaders type game. It effectively allows us a total of 63 different pitches, a potential for the noise to be switched on or off, so we can make a pure tone or a distorted tone, and we can also have a high volume and a low volume. So this gives us a little bit of flexibility to make some sounds. And today we're going to learn how to write this little sound driver on the Game Boy Advance. Now the Game Boy Advance sound that we're going to be looking at today is basically the same as the ones from the original Game Boy Color in the Game Boy. So we're just going to make simple sort of square wave sounds, and we're not going to do anything with digital sound. Now the Game Boy Advance can do digital sound, it's quite capable of it, but it's not something we're going to be looking at today because we're just looking at the basics of making some kind of sounds for you to get started writing a game. And I basically use this in my multi-platform series where I'm writing games that run on dozens of different systems. I need something quick and easy that's going to be consistent. So that's what we're going to be looking at. Let's go over to the source code and let's hear it in action. Okay, so Chibi Sound uses the single byte from the R0 parameter. Basically, it uses a total of 6 bits for the pitch, 1 bit for the volume, 1 being high, and 1 bit for the noise, 1 being switched on. So if I just run this now, you can hear we've got a tone there and it's getting lower, and then the distortion has started. And depending on that bit 6 here, whether the volume's high or low, so we'll hear it repeat soon, and it's now louder. And that's quite enough of that. So that's the kind of sounds we can make with Chibi Sound. As I say, it's just a simple sound driver I use to get something going in my sound and in my games nice and quickly and easily. And that's what we're going to learn today. Now, hopefully, of course, you probably want something more advanced than this, but at least this will be a template so you can get started. I tend to find once you figure out how to turn the sound on, you can start to tweak it and really start to understand it. But often with a new system, you're like, well, I don't know which registers do what with regard to turning the channels on. I don't understand whether 15's maximum volume or minimum. It's a pain to get started with nothing to work on. So hopefully this will be enough to get you going. Okay, now the first thing we're going to do is we're going to turn the sound on, and we use port 4 quadruple 084 here, and that will turn the top bit of that will turn the sound on. So we are writing bit 7 to 1 here. The bottom 4 bits are actually testing the status, they're not for turning the sound on, so it's just this top bit here we're doing. Then we're going to branch depending on our sound that we want to make. If it's silent, we're going to branch down to here. If it's noise, we're going to branch down to here. If it's a normal tone, we're going to branch to this area here. Now, if we want to silence the sound chip, effectively we're turning the left and right channels off, and we're disabling all 4 of the sound channels. There's 4 sound channels in total. The 4th one is noise, 1 and 2 are tone, and 3 is wave, very much like the Game Boy Color. So we're going to be using either 4 for the noise channel or 1 for the tone channel, but we're turning them all off there. Okay, so when we want to make a tone, there's some things we're going to need to do. We're going to need to make changes to our channel 1 parameters here. And the first thing we're going to do here is we're going to set the volume. Now we're doing that with port 4 quadruple 062 here. That will set the volume along with some other parameters, and it's the top 4 bits of the 16-bit value that we want to change. Now the bottom 3 bits are always going to be 1. The top bit is going to be set depending on bit 6 of the parameter we pass, because remember we can have either the high or low volume. So in this case, all of the bits set to 1 will be maximum volume. Okay, next we're going to set the frequency. We're doing this with port 4 quadruple 064. That will set the frequency of sound channel 1 there, and we're just setting that here. We also need to set the initialization bit, the top bit, to 1, which will start the sound off. That will effectively get the sound ready to play, but we also need to set the channel to be turned on. Now we set the master volume with these bits here for the left and right, so we're setting them both to maximum volume 7, and then we need to set the L and R bit of channel 1, and this is effectively saying that channel 1 will go out of both speakers at the same time. If we wanted it to just be on the right, we could just set the R bit there, but we're setting both. So that will turn the tone channel on, and that makes the tone. Now you'll see almost the exact same thing with the noise channel, which is channel 4. This time we're going to set our volume with 4 quadruple 078 here, and you can see the volume is set in exactly the same way. Now the frequency is set quite differently. The frequency uses these 4 bits here, and this is port 40007C. That will set the frequency and set some of the parameters. So we've only got 4 bits of frequency control here. So we're shifting the 4 bits from here. We're ignoring the bottom 2 bits of our parameter because we had 6 bits of pitch in our parameter, and we're shifting them to the left by 2 there for this setting here. And once again, we're turning the sound on, starting the sound with the initialization bit just there. And then finally, again, we need to set the channel to be turned on. Last time we were turning on channel 1, so we were using these bits here. This time we're using channel 4, so we're using these bits here. But again, the bottom bits are all the same. These are just setting the master volume to maximum for both channels. So that's all we need to do to either make a noise or a tone. So there we go. So that's the basics of how we can make sounds with the Game Boy Advance. As I say, that's not really giving a full example of the capabilities. There is a second frequency-based channel that can make tones. There is also a wave channel, and it can do digital sound quite effectively on the Game Boy Advance. So there's a lot more you could do, but as I say, in these tutorials, we just do the basics, and that should be enough to get you started. So there we go. Now, next time we're going to be looking at the Nintendo DS, and we're going to learn how to make digital sounds on the Nintendo DS. The DS doesn't have these kind of frequency-based stuff. It all uses digital samples, so that's going to be something we'll look at then. So if you want to see that, please like and subscribe so you make sure you don't miss that out. If you like the videos, YouTube recommends them to more people as well, which does help me out. Anyway, whatever you do, I wish you all the best with your programming. Of course, you can get the sample from my website, and hopefully you'll be able to make some great sounds on the Game Boy Advance. Thanks for watching today, and goodbye.